All right, I'm going to show you how to create this robot. In the picture here, the video you see, I've got a two-wheel robot that we've set for autonomous driving. It's pretty simple, about as simple as you can get. And their goal is to get around that bottle as many times as they can. And so you can see, just kind of watching it, he's got some pretty crisp right turns. As the battery's dying, you can see the turns just slightly be less, they're not quite 90 degrees. Their goal is to try to get them to 90 degrees. But this was ultimately the winner for this challenge. And so I did this in a classroom with kids that have never, ever worked with robotics, have never done any programming of any type. And this, in just a couple months, this is what they were able to create. So I'm going to take you through step by step all the way from the beginning until you can create this. We'll try to do it in one video. So here we go. So first thing you'll need is to buy an Arduino UNO, is what we're using in this case. There's lots and lots of different types of prototyping boards. I would strongly encourage these. These are about $25 a piece. I mean, you might be able to get them cheaper from another brand. You'll see the one I'm working with is not even an Arduino. It's something else, and it's a little bit cheaper. But what you want to do first is, with your computer, we want to learn Arduino, and we want to install the IDE. So this program's in C++, and so you can either do Windows, Mac, Linux, whatever you've got, and just click on that and download it, put it on your system. Once it's downloaded, this is what a sketch looks like, and so here you've got this void setup. It'll run the code one time here, and then this void loop, it'll just continually run this code faster than you can think, for sure. And so it runs through the void setup once, everything in between these two brackets, and then it runs this code over and over and over again until you shut it off or it runs out of power. So tonight, this was the unit we're going to use. It's my dusty DFRobot two-wheel chassis. And let me show you that. As of this particular time, you can still pick them up for around $34 at DFRobot. I don't work for any of these companies. I'm a math teacher that's created a robotics program, and I've just thrown this stuff together. This was about the cheapest, most basic thing we could come up with, and that's about as cheap as you're going to get it. Like I say, here's what you have. This one's a little dirty. It's been used quite a bit, and so hopefully it'll work tonight when I get it all put together and it's running. The other, not that way. The other thing we need is, if you look here, this DK Electronics, but I'm going to show you where all this, the info for this board is. This is a Motorshield, and we'll need one of these. This is a V1 Motorshield by Adafruit, is the company that originally produced it. And so here is their website. If you just type in, Adafruit V1 Motorshield, this is what you get. This is their original. And if you look, it's been discontinued because they use a V2, but you can pick this Motorshield up cheap. Let me show you that before we move into this. I just did a quick search on Amazon, and $5.89. I have no idea if this one's any good or not. I mean, that's the kind of what you have to go with. This is a high let go. I don't know the company, but looks like it's pretty decent, and for $5.89, why not? So that's fairly cheap. And as of this video, all of Adafruit's stuff is still online to support that V1 Motorshield. So when you go in here, you can click on the instructions. And again, they went to a V2, which is a lot nicer, but there again, it's a little more expensive. And so you go over here to the left to use it. And we want DC motors because we're going to run that chassis for our robot chassis I purchased. And so if you click on that and you go down, kind of tells you some information. We'll talk about it in a minute. But all I do is just copy this data, copy this code, and we'll paste it in to Arduino. So We'll get rid of all this because you don't want two void setups and two void loops. And we'll paste that in, and then we'll check it. Right here verifies it. And let me get that down so you can see it. And you're going to see we got to save it here. So I'll save it as basic motion. Close enough. Good enough. And you'll notice it already throws a error, which I wanted to show you that. So this is how they show errors. It highlights where the error is located. And it's right here at the top. This is called a library. And if you notice, here's our void setup again. And here's our void loop. So it'll run all of this code here one time. And it'll run this code over and over and over again. But it's throwing an error. No such file or directory. And so this include afmotor.h doesn't work. So what we have to do is go in here to Sketch and include library. And we're going to manage libraries and give it just a second to come up. And this is a V1 Motorshield. So once it comes up, you can just hit V1 return for the library. And there's the Adafruit Motorshield V1. And we're just going to install this Motorshield. So now that Motorshield is installing and updating. So now let's check it and see what it is. Sometimes you have to shut down Arduino and reboot it, but I think that you don't have to do that anymore. And they're verified just fine. And so then the next thing you need to do is upload it. Now, you may or may not have, I have this thing hooked up to this robot right now, and I uploaded it to the board. I'm going to show you how to do all that. And what you have to watch out for is in the tools, make sure this says the correct board you have, which we have an Arduino UNO, and then make sure you have the Arduino UNO selected, because I have it plugged into a USB port on my computer, and I'll show you that. So let's start from the scratch here. So if you start with your chassis, one thing you'll need is a platform or something so that you don't have wires touching the wheels or getting tangled in the wheels and the motors are up high. I 3D printed this just simple table. One of my kids actually did. It just happened to be one in my toolbox from a couple years ago. So that's ready to go. I'm going to put that on top of my chassis. Then we're going to take a look at this thing. And what I want to point out to you is these pins right here. This is a 5-volt set of pins. This is ground. And this is A0 to A5. I always fill those up with pins, and also these here. And so there's some soldering to do, and that just shows you it from above. 5-volt ground, A0 to A. This is A0, A1, A2, A3, A4, A5. So you'll want that for any sensors you hook up. And you can also look in here. You have an M3 and an M4. Those are the motors that we're going to deal with. So if you hook your positive and negative to these two, that's M3, and if you do it to the top two, which the one's just out of screen, that's M4. And these are the pins I'm going to use. I'm going to solder those in here, and just another picture of it, and you can kind of see my setup. I've stuck those in here, and we're going to solder all that whole row. And I went ahead and did that. I used this lead-free solder. This is kind of my setup. Nothing fancy for sure. Same as my kids. And then I went ahead and soldered all those pins in. And you can see not a great job of soldering, but not a soldering video. So there is some soldering to do with this. And so, solder $10, $10, $15, and you got a real nice solder. But that's that same board. And again, I use the DK Electronics. Who knows if they're still in business? Maybe they are, maybe they aren't. Doesn't matter. Like I say, this is a $5 board. And so I soldered these pins in so I can plug things into them. We're not going to on this video, but I always start with that because later on, my next videos are going to go into detail about how we hook up to different things. So the next thing we need is a battery pack. So I've got the table hooked up, And I'll move things just a little bit, but this shows the table glued on, the wires to my 2 motors. And this is the battery pack I use, and I'm hooked to a little plug-in that'll go straight into the Arduino UNO. So let me show you that. And this was the actual purchase I made. These are 4 by 1.5 volt AA battery holders. They were $10. So this thing's getting a little expensive. There's some, but you get 5 of them. So I'm doing this for a classroom full of kids, and so it does. You think about buying textbooks. This is way cheaper. So we've got this. $10 for 5 of these things. I ordered a couple of them, but you'll need that to power your robot and your Arduino. And the other thing you'll need are these 10-pack of 2.1 millimeter by 5.5 millimeter male CCTV camera DC power adapter connectors. These plug right into your Arduino, and in the back there's a little plug you can do that, and it'll run both your battery, it'll run both your Arduino and your motors, so it's kind of nice. And there's your, not that that's the way you should do it every time, but just to get started, if you're new to this, this is what you need. And you can see on there, there's positive and negative in each of those. Like right there's positive, negative, I do believe. Yeah, and you just hook those wires in, tighten them up, and plug it into your Arduino, and you're ready to roll. And I'll show that also all put together. All right, so you can see I use a Sunfounder Uno. I don't know the price on this Sunfounder. It's probably a little cheaper. Like I say, I don't advocate for any of these companies. I buy it and it works, and we use it. And so you can look at my battery pack, and it's plugged in here. That's that adapter. Slightly different than what I showed you, but it's the same thing. You got a positive, red's positive, black's negative. Plugs into this adapter in the back. Here it is from above. You can see I got it glued up, and it's plugged in to that adapter. We're doing good so far. The other thing I might show you is when you line these up to plug it into your Arduino, they stack on top of each other. You can kind of see where these pins line up on this thing. You don't want to put it in the wrong location. That'd be fairly easy to do, but you can see how they just line up and plug in, and you just press that in. I think I have it. There it is from the other side, and there it is from the top. Oh, and that's it. Once you have it, all pushed in tight, and we got the battery pack hooked up, make sure your battery pack is shut off, because it might just start driving on you if you've had this hooked up before. But and I just put the positive and negative in. I think that's that M3, and then you'll put 2 wires in here on the M4. And it doesn't matter for now. It doesn't matter which way you put these, but the polarity. If you got to decide. I think I'm going to make this side of my robot forward and this side of my robot backwards. And so when I put in the forward command, I'm going to want to make sure that my wheels are turning forward. So we might have to flip those. And I think I have another video. Yeah, that's just another picture of me doing that. And there it shows you, I hooked them. That's probably backwards. I guarantee you that's backwards. I think it goes black here, red here, black here, red here. I think this one's right. These are going to run opposite directions on me, which is fine. I'll just switch them, but I haven't got to that point yet. This just kind of shows you my setup that my students have to deal with. So this is an Apple computer, a MacBook Pro. You got the dongle and all that stuff, but you plug it in here. This allows you to, the USB hooked into your Arduino allows us to upload the programs that we create with our computer straight into that, and then we'll be able to test whether we're driving forward or backwards. Don't mind the dust, but here's the same setup. I've got it hooked into just my USB. This is what I'm using currently on this computer. Wow, things are dusty. One of these days I'll dust. And here's just another nice video of this that shows this plugged in. So just plug it straight into your USB. And the last thing before we get into the programming, if you look at that Pololu, that DFRobot chassis, it's a 50-to-1. Pololu is another nice company to buy these, and these gearboxes, the one thing I would do different is I'm going to start next year making my kids create a cover that snaps on here. They'll 3D print something to keep hair from getting inside of these gears, because I'm having to I had to order a lot of these. They're about $16 right now, which kind of expensive for the motor and the gearbox, but this is kind of what you're looking for. And this is just the low power 6-volt, but that's in Pololu. So here's the entire program, back to that basic motion. And I did upload it. I hit this button on the upper left. And let's see what happens. And what happened when I hit that was nothing. And I forgot. So this is just to run one motor. And this is called frank encoding, when you just copy it and paste it in. You know, if you do this, then you're going to have to spend some time playing with this and really learning what this stuff is. And so the first thing we're going to need here is, you know, this AF DC motor. This sets up your motor. And this tells you what pin you're hooked to. So right now this is hooked to pin 2. Let me show you where that's at. So this picture shows it pretty well. Right there you can see an M1. And so that would be motor 1. So if you plug in your wires here, that's motor 1. Here's an M2, that's these two, and it has a nice wire. The middle one's just a common ground. These sets of pins are, if you want, you could take this, unplug it, take your hot and your ground wire and hook them in here to these two and power the whole board that way. And then if you look down here, M3, that's your third motor 3, and then here's M4 for these two. And I'm hooked to motor 3 and motor 4. So when I go back here, I'm going to change this. I'm going to go, this is my motor 3 now. Okay, and then, you know, change the comments. When you have 2 forward slashes, this is a comment. So I'll change that to motor 3. We'll ignore the 64 kilohertz, you know, pulse wave modulation. We're not really concerned. You don't need to know anything about that really to make this work. All we care about is making it work. So we'll copy that. I'm going to paste it. And we're going to call one, we're going to have a right motor and a left motor. So, you know, motor right, motor left. And I'm using camel case. You do a capital letter on your second words. So this is my right motor now for 3. My left motor will be 4. So anytime I want to call that motor now, I have to use motor right, motor left. And so I'll change that to a 4. Okay, then we go into the void setup. So it's going to run this code along the top. It's going to run this void setup. This serial begin 9600. This allows you to communicate with your robot with your computer. And then this serial print line is just going to print, and I'll show you a serial monitor. It'll just say motor test when you check it. It's more, I use these to just kind of check things, make sure that it's running that line of code. But what we want to make the motors work is this line of code. So we set the speed, you know, remember we changed the 2 motors. So this is now motor right, speed 200. You know, 200 is a little fast. I typically start my kids out at 125 just to get them going. And they can adjust it. They can go faster, slower. They'll notice that they really struggle with that speed. And then we'll copy that and we'll paste it. And we'll change this to a left. So now we have a motor right speed at 125 and a motor left speed at 125. So we've set our motor speeds, and now in our void loop, you know, again, it'll say tick, which will mean it runs it forward. This delay 1000 means it'll wait a second, and then it'll say talk. So it'll be running forward for a second, then it'll run backwards suddenly for 1 second, and then it'll release and stop for a second. There's your 1 second. So we need to go in here and change these so that we've got a motor right running, forward, and copy. And notice it's all capitalized. You know, forward is capitalized, so and it comes out. So now it's going to run both motors simultaneously. We'll change one to left. And then, you know, and same down here. So we got motor right. I'm going to just copy that whole thing now. I'm going to paste it in place of this. And we want it to go, and in fact, it doesn't really matter. We'll go ahead and change that to backward. And if it comes out blue, light blue like that, you did it correctly. And we'll do the same here. Backward. Those are just commands out of that library we loaded. And then we'll do the same for the release. So I'm going to paste those 2 lines of code, change these to releases. And then we'll check our code first, and it'll compile at the bottom. So I hit check, it compiled at the bottom. As long as nothing comes up, it means it's good. And so then we're going to upload it. And I don't have my board plugged in, so it's going to pop an error. I'm going to show you that. So it's I tried to upload it. Error while uploading the sketch. And it kind of tells you something's not quite right. Well, right there it tells you COM3 is can't open the device because I didn't plug it back in. So let's do that, and then I'll show you a video of it running. And after loading it, you can tell right here that it's running opposite direction. So my polarity is reversed. So I'm going to change one set of those. So I'm going to put the blacks to the inside and the reds to the outside. And then they'll both turn in the same direction. Alright, so I've got them. I switched those wires around, and now you can see that they're moving in tandem. Oh, and of course my fingers are in the way, and I looked to the wrong side. There we go. Well, let me move my arm around here. Alright, but there you can see my my grounds are to the inside, my powers to the outside. And if you wanted to just exactly reverse those and put your powers to the inside and your grounds to the outside, you can just decide which way you want to drive forward. And that's going to be up to you and your kids. And so that's pretty much it. And so there's the code. There's $80. I just added everything up around 80. For under $100, you can get all of this stuff, per robot, and that's probably on the expensive end. If you buy bulk, for a lot of kids, you're probably going to get, each set of robots for under $50. And so this is the only code you need to drive forward and backwards. And then my next step is I have kids start doing right turns and left turns. That'll be in the next video. So this will get you started for driving forwards, stopping, and then driving backwards. You flip, if you want to turn, you start flipping these. So you'll run your right wheel forward and you'll run your left wheel in reverse, or you'll release it. Most of the time my kids release it because they don't want a quick turn. They're more after precision rather than speed. So all right, so that's the step 1 in creating a 2-wheel robot. Well, the first set of steps anyway. And so hopefully this video helps. If it helps, let me know. I'll make more of them. If not, I will discontinue making more of them. So see you later, and have a good time.